Hello everyone. In this video I'm going to show you how to sketch inverse hyperbolic graphs, how to derive the equation for r cosh, and how to use hyperbolic functions to solve equations. Hyperbolic functions are the inverse counterparts of sine, cosh and phan of x. And to sketch the inverse hyperbolic graphs, we'll consider the principal branches to ensure a one-to-one correspondence. So what this means is, for cosh of x, I'm only going to consider this part of a curve, because at this part it is a one-to-one function. And to find the inverse cosh of the r cosh, I'm going to reflect it in the line y equals x. So we'll make a note here, and this is the line y equals x, and this is cosh of x. Okay, so to sketch an inverse function, we need to reflect the original function in the line y equals x. So we can see that this point is reflected in the same distance from the mirror line to create the image point, which is approximately here. And now as x gets bigger, we start to approach the mirror line. So this point here is reflected to approximately here. And then as x continues to increase, we get further away from a mirror line. So the sketch of r cosh of x looks a little bit like this curve here. And to work out this value, we need to consider cosh of x in exponential form, which is e to the x plus e to the minus x divided by 2. I'll just make sure this is cosh of x. And at this point, the x value is 0. So when you substitute x equals 0 into here, we get e to the 0, which is 1, e to the negative 0, which is also 1, and 1 plus 1 divided by 2 gives us a y value of 1, which means the reflected coordinate will be when x equals positive 1. And this explains our domain where x is greater than or equal to 1. Okay? So as we move on to the sine of x, well, you can see that this is a one-to-one function throughout. So the domain is true for all values of x from negative infinity to positive infinity. And because sine of x passes through the origin, this point is invariant. And as x increases, we move away from the line. So this distance is approximately the same as this distance. And the same is true when x is negative. As the magnitude of negative x increases, again we move further away from the line, the mirror line. So again, this distance is the same as this distance. So this is the curve for the r sine of x, from negative infinity all the way to positive infinity. Okay, so now we'll look at y equals phan of x. So the first thing we need to think about is that phan of x passes through the origin, so the inverse will also pass through the origin. And as we increase our x values, we move away from the mirror line. And the same is true when x is negative. But to work out the domain, we need to work out the equation of this asymptote and this asymptote. So we need to write phan of x in exponential form, which is e to the 2x minus 1 over e to the 2x plus 1. And at this point, we can let x equal infinity. So as x tends to infinity, well, e to the 2x will tend to infinity, and this negative 1 and positive 1 will become negligible. So we'll have infinity divided by itself, which is 1. So this asymptote will be when y equals 1, which means this asymptote on the domain will be when x equals 1. And if we now look at when x tends to negative infinity, well, we get e to the 2x, which is e to the negative infinity, so these become 0. So then you get negative 1 divided by positive 1. So phan of x, or phan of negative 1, will become negative 1. And this gives us the equation of this asymptote, y equals -1, which means our fan of x will have an asymptote at x equals -1. So we can see then that the domain, the magnitude of x will always be less than 1, okay? Now let's move on to deriving the equation for our cosh of x. Okay, so in example 2, I want to show you how we can write our cosh of x as a natural log of a function in terms of x. And the way we go about doing this is, we say y is equal to our cosh of x, and then we'll take the cosh of both sides. So this r cosh and cosh will cancel on the right hand side. So what we're left with is the cosh of y will equal x. And we can write cosh of y in terms of e. So this will be e to the y plus e to the minus y over 2, which will equal x. Now our aim here is to make this y the subject of the equation. So we'll multiply both sides by 2, and we get e to the y plus e to the minus y equals 2x. And then we'll cancel out this e to the negative y by multiplying both sides by e to the y. So we'll multiply e to the y by itself, and we get e to the 2y. When we multiply e to the y by e to the negative y, we add these two powers, so we get e to the 0, which is 1, and this is equal to 2x e to the y. So now I'm going to make this equation equal 0. We get e to the 2y minus 2x e to the y plus 1 equals 0. And now you might notice that we have something that looks like a quadratic, where you've got a power of 2, a power of 1, and a constant. So to make y the subject, we're going to use the method of completing the square. So we have e to the y, we'll halve this term here, so minus x, we'll square this, we'll complete the square by taking away the square of the x, so minus x squared, we'll add back in the 1, and this is equal to 0, and then we'll move these terms over to the right hand side, so we get e to the y minus x squared is equal to x squared minus 1. We'll cancel out this square by taking the square root of both sides, so e to the y minus x will equal plus or minus the square root of x squared minus 1. And then we'll move this negative x to the right hand side, so e to the y will equal x plus or minus the square root of x squared minus 1. And then we'll take the natural log of both sides to cancel out this e. So we get y is equal to the natural log of x plus or minus the square root of x squared minus 1. But we can't find the natural log of a negative number. So this negative term will go. And what we're left with is the r cosh of x is the natural log of x plus the square root of x squared minus 1. Okay? And we can use a similar approach to find the r shine and the r fan of x. Okay, so now that we have an equation for r cosh of x, let's explore how we can use inverse hyperbolic functions to solve equations. So to solve the equation, sine of x is equal to cosh of x over 10, we're going to divide both sides by the cosh of x. Because what we'll have is the sine of x divided by the cosh of x equals fan of x. So now we have the fan of x is equal to 1 over 10. And by taking the arc fan of both sides, we're left with x is equal to the r fan of 1/10, which is approximately 0.1. So that wraps up our tutorial on inverse hyperbolic functions. I hope you found it helpful. Thank you for watching, and be sure to join me in the next video. You can download the full lesson from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.